Okay, so Topcon GB Limited is the national distribution arm for the Topcon Corporation. It's a company started in 1932, primarily manufacturing in the US and Japan. We supply, train and support many contractors all over the world with solutions for improving efficiency on infrastructure projects, large and small. Some of our technologies include the scanner on Google Street View, optical medical instrumentation, unmanned aerial vehicles, systems for improving crop yields in agriculture, and software for machine control and construction. So Digital Construction 4.0, the next generation in construction. This is the motto under which we presented ourselves at the Bauma show earlier this year in Munich. Life is increasingly demanding. In construction, we live today in a 3D world, work in a 4D environment, with 5D constraints and 6D requirements. Industry 4.0, the fourth industrial revolution, is looking to help these elements and embraces automation, data exchange and manufacturing technologies. In the same way, Digital Construction 4.0 shows us the possibilities to be part of this change, and a significant role of this concept will be played by software and machine control, giving us our objective of connecting the virtual and real construction worlds to provide a continuous representation of reality. One of the software packages we do is Dynaroad, and Dynaroad software gives you the optimization of a mass haul plan, which means that it works out the best route for the dump trucks on a construction site to move the various types of material from where they are to where they need to be. By planning the routes for the entire site, expensive mass deficit and surplus of materials are easily eliminated, and the software also allows for the planning of borrow pits, crushing plants and tipping areas. Dynaroad can combine Gantt and critical path method visualizations, and along with location-based scheduling solves many construction problems. Any dependencies affected by a delay on one part of the project automatically get updated and shown across any of the relevant views. Dynaroad is also able to output to Primavera and MS Project. Dynaroad can give you systematic control of actual workflow during construction through dynamic completion degree reports. Haul truck cycle counts can be imported into the software for a complete project status report, giving actual amounts of material moved compared to the original planned schedule. Dynaroad has been recognised and certified by the Swinburne University of New South Wales, Australia, as being one of the few planning and scheduling software packages that reduce CO2 levels during construction. And the HS2 mass haul team are currently using Dynaroad software to assist in the development of the earthworks balance for that project. So I've just got a quick example of a mass balance. Here we've got the alignment of a road. To construct the road to the required design, the mass of earth on the right needs to be used as fill material. Now we can see by using the software has come up with a calculation that there's going to be 10,000 cubic metres shortfall. So what you can do either in the design stage, you can, sorry, should have said that I've put a figure in there for 50 grand for the extra work there and obviously resource. So what you can do in the bid plan or in the ECI, when you're working with a designer as a contractor, you can look to improve the design to actually get that material to fit better into the cut areas, or the fill areas, sorry. So we've got a savings of £50,000 on that scenario there. A scenario like that would just be one part of a large infrastructure project, so especially a linear project. As you go along, you've got lots of cuts and fills, bridges to construct to get to the desired result. So once you've decided how you're going to do the job, you need to choose a type of machines you're going to use. We can install on excavators, dozers, graders, pavers, compactors for measuring pass counts, and also drilling and piling rigs. All of the technology we make available is based by making the construction process more productive by using less people, less time, less materials and less fuel. Increased productivity needs to be provided through the use of a digital design model, be that the project a road, a railway or distribution park or a housing estate. The digital model reduces the risk of human error on the job site and cuts down the need for rework. More and more today, the management of a site is being improved for the whole project through BIM, with the infrastructure works being separated out into the various packages of earthworks, foundations, drainage, roads and vehicle parking areas. In the picture here, we've got Junction 19, the Skanska project, running north to south. There is the M1, to the west is the M6, and to the east is the A14. The centre and right-hand images are the carriageway with a balancing pond to the left of it. And then we've got visualisation. This is what the engineers in the Skanska office would see before they sent the model out to the machine. So they can actually drive the model as they've constructed it and check for any erroneous levels to make sure that there's no bad data in there before it goes out. So being more productive is all about the data. We need data from various sensors to provide us with the positional information to get the cutting or laying edge of a construction machine to the required design level. Primarily, we use GPS to determine the position of the machine on the planet. Additional pitch and roll and angle sensors are added, and all this data gets computed into a box and then shown to the operator in the machine like that. So we've got a picture there of the actual screen the guy uses. On the left-hand side, you can see the machine in profile. At the bottom there, you can see he's working to an offset of minus 0.3 of a metre, minus 300. And on the right-hand side, it's shown that he's got 59 mil to get down to where he needs to be. There's also a grade indicator on the right, red showing high, green would be on grey, and blue would be underneath. So SiteLink is a cloud-based system that allows remote access to the machine's control box for upload and download of data to and from the machine. Previously, if a model revision came in, it could take a full day of driving, depending on the size of the site, to update, say, 10 machines with a USB stick. Now, this can be done at the click of a mouse, saving time and fuel and allowing operators to work with the latest data straight away, thus saving rework again. Instead of surveyors driving out to measure the ground for progress volume surveys, those volumes of material moved by the machine and other production info gets reported in real time to a server for management to access to see actual progress against planned. It used to be said that you cannot manage what you do not measure. However, we are now encouraged to say you cannot manage in real time what you do not measure in real time. All the data is available to make construction more productive, so that people do not have to drive out into the field and spend time collecting the data as they did before. So I've just got a couple of industry studies to show you now. The first one is by the University of Reykjavik. It's a 70-page document. If anybody wants it, I can send it to them afterwards. But those are the headlines from that study. What they dug 2 trenches, 160 metres long, both with changes in grade and direction, identical trenches. And you see from there the technology, as well as doing it faster, saved 77 litres of red diesel. Typically an excavator driver digging a trench will always tend to over excavate, and this results in more pipe bedding needing to be put in. As you can see from the bottom line there, the material in extra 91 cubic metres, or approximately 180 tonnes, which is about 7 or 8 or 9 lorry loads. Another one which was done last year, 2 roads constructed about 140 metres long, one using conventional methods, batter rails, string lines, profiles, and the other one using GPS and total station technology, along with unmanned aerial vehicles. Again, I've got this in full detail, so if anybody wants it, but for us today, that's the real highlight of it. 37% less fuel consumed, thus saving 12 acres of forest. So just in summary, from these 2 industry reports, I think you can see that using technology in construction saves fuel, materials and resources, which all have a link to carbon, and by using these systems overall leads to a leaner, greener and more efficient construction site. Thank you.